Hello everyone, and welcome to another lecture in this control system lecture series. So today we'll be discussing about the closed loop and open loop system. And so, what is a closed loop and what is a open loop? Before diving into that part, let's revise our concept, like what we had discussed about a system, like more to say control system and control theory. If you remember what a control system is the this like with the block diagram. This is a generic block diagram. So this is the system. So what system does is like you give some output input and it will give some output. If the system has some states, given some input, how the state changes. So that is called the system. But what is a control theory? Like if you want some output, like this, what I want a particular R. So how should I manipulate U? So how should I manipulate my U so that I will get the desired output? That I want some particular output R. That concept is called the control theory. This we had discussed in an earlier lecture. So, just an example, if you have the exam is your system, some mathematics exam or something, you want some 95% or something. So, what should be your strategy? You need to study for few more hours, like 6 hours a day or something like that. So this is called a strategy. We need to strategize according to our what we want. If we want just pass, just clear the exam 30%. So definitely our U will be lesser than what we had to do for 6 hours. Sorry, for 95%. So coming now to our most important question: what is an open loop system and what is a closed loop system? So let's discuss the open loop system. So, as the name suggests, open loop system is open. Like the loop is open. What do we mean by the loop? If this is the G, we give some input and we get some output. There is no like my input or like my input does not know what is my output are. There is no feedback or any kind of loop or something which loop means it's a close, like when we say it's a loop, like it's a kind of closed contour, not exactly contour, it's a closed strategy. But now if I am saying the open loop, like that means I only give some u and get some output r. My r does not manipulate my u. If I am manipulating my U according to my R, like some manually, then that is called open loop system. And if I am changing like some smart sensor or something, then we'll call it a closed loop. Like we'll discuss that. So, what is an open loop system? Let's take some example. Nowadays, many things are coming, the smart inverter, like smart oven, smart washing machine and all. So beforehand, like before this smart technologies came, there used to be one, like this kind of micro oven, like must have, you must know. So suppose this is a micro oven, this is the griller plate, and there's a wire. Okay, leave it. Just okay. So you put something, some food inside it or some water to boil. So and put it for 5 minutes. The knob, set the knob for 1 minute. Okay, and you get the output. Some, like, then what happens? Even if the water, the for boiling the water, the temperature reached around 80 or 90 degrees Celsius at 40 seconds, it won't stop. It will continue because my knob says like you need to run for 1 minute. There is no channeling up the temperature to the control input, like the knob. So nowadays, what happens, like what we do have, like if the temperature reaches this, it automatically switches off. So that's called closed loop. We will discuss that later. So this is like we just set for 1 minute, for 1 minute, and get the output. Like after 1 minute, whatever the output is. This is called open loop system. Another example, better example, you may say. Suppose like many of you are engineers, I feel. So there is a, suppose there is a robotic competition, what you have, like you have some robot club or something, you are designing, so pardon me for the drawing, some robo, which robo means just four wheel system. My drawing is horrible, I know. Okay, and you need to follow some path, like I will design some path like this till here. This is your goal location. Simple enough. You say the robot to this. Suppose this is for 50 meters. Okay, go straight. Suppose you know the at velocity 5 meter per second for 10 seconds. Okay, you have the timer and everything. So everything is going smooth. Like your, just 1 second. I'll So as time progresses, your vehicle is going this, like this. Suppose at this moment, when the robo is at this location, what your opponent sees, there are some unethical opponents, suppose, they see your vehicle is doing so good work. So what they will do, or maybe some due to some other external inputs, what this robot, like this gets a little tilted like this. Some path, like some external disturbance comes from this side, uh, so it drives it little far. So as I had mentioned, go straight at velocity 5 meters per second for 10 seconds. My robot will continue in this direction rather going in that direction. It will continue in this direction, and finally it will reach somewhere here. So what I intended was the green line, but what I got is the pink line. So definitely, if it final location it reaches here, definitely it won't, like our objective is not satisfied. So will just lose the competition. So whose fault is this? Do you say like, hey robo, you don't know how to go? So no, it's not the fault of the robo. It's the fault of the strategy. What we had mentioned, because it's an open loop. You just said go straight for 5 seconds, 5 meters per second, but for 10 seconds, it does that. It's there is nothing wrong in the robo. So where did the issue happen? Because it was an open loop system. Another example we'll take is like, suppose you are moving in a car, okay, some basic ambassador kind of car, not so some fancy car. So you are going, you are saying like, we'll go in a constant speed or constant velocity or something for about 25 meters per second, just drive. So you set your the gas pedal at some like, if this is the gas pedal, so you put it, you hold it at constant angle like this. So your vehicle is going at a constant velocity. Suppose you have some hilly area or some downhill. If you maintain the constant as like gas pedal angle, do you think your vehicle will be sustaining to the same 25 meter per second? Definitely not. But while you were going through a straight line, it was doing it. So where did the um, uh, issue or the wrong thing happening? Because of the open loop. Suppose now, if we close the loop means if we add this sensor, some sensor, like here some temperature sensor, that whenever the temperature reaches, like this is the temperature sensor detects the temperature, and what our strategy will be, reaches 85 degree or some value, then switch off. So here we'll some in the knob we'll add that information. So whenever the temperature reaches the knob will automatically get to 0. And what about this system? How to incorporate it? Let us assume we have a sensor which detects the path, the green path, some camera, some lidar, or some reflecting sensor, anything. So if that detects it, so whenever when the vehicle the mm, got into some other place like this, okay. So at when it will be coming here, it will say, "Hey, wait, this is not the path I wanted." So then it will gradually de decrease its angle and come back to this. Then again, it will be following this path. Okay. So that sensor, any sensor, we will add to its feedback. Feedback means whatever output I am getting, is my input depends on that. Is my does my input know what output I am getting, so that I can strategize accordingly. Suppose in this example as well, the if I have some speedometer, like if let's draw a block diagram for this. This is my gas pedal, and this is my velocity output. This is input some. Okay, so this is my car, and velocity input is the gas pedal position. If I add a speedometer in the loop and input velocity, reference velocity, or reference velocity, which is 25 meter per second. So if I have some speedometer and I incorporate that information to my driver, then when the driver feels like when it's a hilly path or some uh, hilly path, then it will be increasing the gas pedal so that the vehicle can maintain at 25 meter per second. When it's downhill, then remove like relax the gas pedal a little bit so that you will be maintaining at 25 meter per second. So uh, let's revise what we said. In a open loop system, we don't have any like the control input doesn't have any information about the output what we are getting. So whatever strategy it's predefined, it will just follow that. But in a closed loop system, the input does have some information about the output signal. That's why it will incorporate that data into its signal, and it will drive the system accordingly. So let's, as we have mentioned the block diagram, I would like to introduce another concept here. If our system is G, I will use some other color maybe green. This is G, and I'm using some controller which I will be discussing later. And we incorporated some signal, some sensors H to the path. Then this is our output. This is our reference. So my error, like what how I am deviated from my reference, that will drive. This is the error is equal to like the reference. If I take V and output I am taking as Y, then it will be V minus Y. So the this will drive my system G. So if I write it down, my error E is nothing but V minus Y into H. Okay, so I can write like my Y is equal to Y into H to avoid the confusion. E into this Y is E into D into G. Simple. So that means my E is equal to Y divided by D into G. So I can write also V minus Y into H, Y into H error is equal to Y by D into G. So manipulating this, I can get Y by V is equal to what I am getting? It's dg by 1 plus dg. So this is called a transfer function. So why it's called transfer function? Like the transfer function means I am giving some input, I am getting out some output. So the transfer function defines like how my output is changed by our input. So how my y varies when I change v. So that will be defined by this transfer function. Like how my input, whatever I'm giving, like the if this is a system, this is the u and this is the y. So how my u, this u changes, the transfer is transferred in into y. That function is called the transfer function. So I will be explaining a little more about transfer function in the next lecture. Thank you.